we're going to talk about how to solve a more general cosine equation, one that has a different sinusoidal axis, amplitude, period, and phase displacement. This is from the fox problem, and specifically we want to find out when were the foxes first endangered, between what two times. So we want to find two times between which the fox population dropped below 300. So in other words, I'm looking specifically for y equal to 300, and I want to solve this equation. So I'm going to plug in 300 for y. So I have 300 is equal to 500 plus 300 cosine pi over 2.2 times x minus 0.7. Now you could do this the same way if you had different phase displacements, but you'll end up with different answers. You'll end up with the same group of answers, but the answers that come up in your first two answers you get may be different, but then you'll have to add or subtract the period to get other answers. So you'll see this at the end. So in order to solve this, the first thing I want to do is isolate my cosine function. So I'm going to subtract 500 and then divide by 300. So subtract 500 from both sides, and I'll have 200, negative 200 is equal to 300 cosine pi over 2.2 times x minus 0.7. Then divide by 300, and I'd have negative 200 over 300 is equal to cosine pi over 2.2 times x minus 0.7. I could also reduce that to negative 2/3. Now I want you to notice that at this point I can't do anything else until I take the inverse cosine of both sides, because all of the things that are inside the cosine function cannot be accessed until I get them outside of the cosine function. So I have to take the inverse cosine to get that, find access to what's inside there. So inverse cosine, I'm going to go ahead and reduce this to negative 2/3, is equal to pi over 2.2 times x minus 0.7. Now I could continue solving for x and I would get one solution, but I don't want just one solution. I want all of the possible values where the fox population is at 300, and then I'll see where it drops below. So at this point I'm going to put a big stop sign, stop, and insert, and then use the general solution for inverse cosine of 2/3, negative 2/3. So on my calculator, I'm going to do inverse cosine of negative 2/3. It is not a special angle, so I can't get an exact value like I did with pi over 3 in that previous video. So on my calculator, here's my graph here. I'm going to do inverse cosine, so trig inverse cosine, negative 2/3. Okay, and that gives me an unhelpful answer. So I'm going to go up and do this again. Only this time I'm going to do Control Enter so I can get a decimal value. Okay, this tells me that the angle, or the time in this case, 2.3052, is a place where the cosine value is equal to negative 2/3. So let's go look at the graph here and write this down, 2.30052. So I have 2.300, I'll just go ahead and stop there. Now let's look back at the graph. So at 2.3, so here's 1, here's 2, here's 2.9. 2.3 is about right there. Here's 300 on my axis, 300. So I'm looking for a point here and here specifically. 2.3, that looks very reasonable for being this point right there. But I need to know this point also. So I need to find another value. So this is where we think about the fact that inverse cosine of this, remember this, when we're just dealing with this part, we're talking about the secondary angle for inverse cosine is always going to be the opposite of the first. Remember we looked at that graph on the previous video? We saw opposite angles had opposite trig value, had the same trig value for cosine, I'm sorry. We had opposite angles but the same trig value, so we're going to look at that same thing here. an opposite trig value. Okay, so negative 2.3005 would have the same trig value as the same cosine value as 2.3005. Now you might be saying, wait a minute. This graph isn't symmetric about the y-axis. That negative 2.3, that's not going to give me a place in a same spot on the graph. You're right. You're absolutely right. But we're not done solving yet. So this part right in here, I also have to add plus the 2 pi n, because if I kept adding 2 pi, I would keep getting additional angles. So basically what I'm doing is I'm writing the general solution for just this little part of the graph, not with all this stuff taken into account yet, just this little part. I'm saying for this particular cosine value, those would be the first two angles that would have that cosine value, and then I would add 2 pi to these two angles, or subtract 2 pi. That's what the n could be, either positive or negative. I can add and subtract angles to get additional angles. So I'm going to put a little bracket around here. This is the general solution for inverse cosine of negative 2/3. Then I'm going to finish solving. So the next thing I have to do is get rid of what's outside the parentheses, because I can't deal with the negative 0.7 until I get rid of what's outside the parentheses. So I need to multiply both sides of my equation by 2/2 divided by pi, or times 2.2 over pi. Now, on the left-hand side, basically I have three things multiplied together. These two things are reciprocals of each other, so they're just going to cancel out, and it's going to leave me with the x minus 0.7. Over here, this basically serves as a parenthesis. There's two different lines in it, but it's a parenthesis. So I have to multiply the 2.2 over pi times both of these. It's going to affect both of those numbers. So on your calculator, let me show you kind of an efficient way to do this. I'm going to say 2.2 divided by pi. Make sure you don't do it the other way around. We're multiplied by the reciprocal to undo things, remember? Times, and then I'm going to make some curly brackets. That makes a list. So control and then your right parentheses, and then I'm going to go up and grab this number, comma, then negative, and then this number again. So I have positive and negative that number. So when I do 2.2 over pi times these two numbers, I get 1.61101 and negative 1.61101. And actually, I could do something even more. I could say 2.2 pi, and then I could do 2.305 plus 2 pi n, negative 2.305 plus 2 pi n, and I could actually get the entire thing here. But let's just go ahead and do 2.2 divided by pi again. And times, what was our period? 2 pi. That just gives me 4.4. Interesting. 4.4 is the period of the Fox function. Okay, so I'm going to take these numbers back now and put them into my equation. So I'm bringing this over here to kind of have sort of handy so I can see these numbers. So when I multiply 2.2 over pi, once again this does not show very well, this 2.2 over pi is this number right here. I get 1.6110, that's good enough, plus 4.4n, and negative 1.6110 plus 4.4n equals x minus 0.7. So now I've changed the period. Now I'm not looking at the number 2.305. Oh gosh, I just did something terribly wrong here. You know what? I just realized I did something wrong. When I said, let's go and see if 2.3 makes sense up on the graph, it shouldn't make sense on the graph yet. It's actually probably kind of close to the correct answer, but I don't have the original. I was just looking at inverse cosine of negative 2/3. I hadn't taken all of this into account yet, so scratch what I said earlier about that 2.3 making sense. Now I need to add 0.7 to both sides. Now when I add, addition does not distribute. So it would be 0.7 plus 1.661 over plus 4.4n. I can't add 0.7 to 4.4n. They are not like terms. This is multiplied times n. I can only add the 0.7 to these two numbers. So I'm going to go back to my calculator, and I'm going to pick up these two numbers and just add 0.7 to them. And that adds it to both numbers. Notice, look at that, I got that 2.3. I really was close, but not 2.3005, 2.31101. So here are my two solutions. Negative 2.311, and I think I'll just copy and paste this again so that I don't have, it's hard to go back and forth on my stuff here. So here's my solution. So 2.31101 and negative 0.91101, good enough. I really probably don't need that extra one. I'll just do that. Equals x. So this tells me two of the values where the fox population is equal to 300. So let's take a look at those two. The 2.3, that's this one right here. 2.311. The negative 0.9, that's right here. But that still doesn't answer the question, because the question is between what two values is the fox population first endangered? Between these two values, the fox population is greater than 300. It's these two values. And besides, I can't use the negative one anyway, because that's before we started taking the population of foxes. I need to know this one. So how do I get from the two values I got to this number? Because here's where the fox population is first endangered, is this little area right here where it drops below 300. So how do I get this one? Well, I can add 2 pi to my previous answers to get more answers. No, I can't add 2 pi. What's the period here? I add a period to here to get to this number. I would add a period to here to get to this number, find another value. What is the period of the fox population? 4.4. If I add 4.4, and that's what I'm showing right here, I can get additional solutions. So 2.3110 plus 4.4, negative 0.9110 plus 4.4. So once again, back to the calculator and just add 4.4 to both of those numbers. So go up and grab these two numbers plus 4.4. So here's my other numbers, 6.7 and 3.48. So 6.71, 3.49. .71, 3.49. So if we go back up to the graph, here's the 3.49. Here's the 6.78. So my solution would be that between those two numbers would be the first time the fox population would be endangered, between this one and this one. So between 2.3 and 3.5 years after we first started recording, the fox population is in danger. So I will write that down. You might want to pause for a second and while I type out that answer. Okay, there's our solution to the problem.